Hey everyone, Professor Baldwin here. Today we're going to look at how to solve a rational equation, and then we're going to check our answer. When you're solving a rational equation, remember it's just fractions, and in order to add or subtract fractions, they have to have a common denominator. And most of these rational expressions are going to have either a binomial or a polynomial of some sort. Notice that the third rational expression has a denominator of x squared minus 4. Right away, you should realize that that's a difference of squares and that we can factor it. And it factors to x minus 2 times x plus 2. If that doesn't jump out at you, look at the other denominators that you're given, and you might get a clue as to what your polynomial factors to. Now that we know what that third denominator factors to, x minus 2 times x plus 2, and it's a composite of the previous two denominators, we know we're going to rewrite all three of those fractions with that denominator of x minus 2 times x plus 2. So our next step is to rewrite. And I'm just going to write down that common denominator for all of them. Now, the very last fraction already had that denominator, so the numerator is going to stay the same as 6. Now we're going to look at the first fraction. The first denominator was x minus 2, which means the only component missing was x plus 2. So we need to multiply x plus 2 times our given numerator, which was 1. Then we can look at the second rational expression. And the denominator there was x plus 2, which means we were missing an x minus 2. And we're going to multiply that x minus 2 times the given numerator, which was 1. Now, the next step is to simplify those numerators. Well, they're both times 1, so it's x plus 2 and x minus 2. And we can rewrite that denominator again. Now we can combine the like terms on the numerators on the left-hand side. Because the denominators are the same, we'll combine them and they'll have that same denominator of x minus 2, x plus 2, and we add the numerators. X plus 2 plus x minus 2. And then we combine those like terms. So the x plus the x gives us 2x, and 2 minus 2, they cancel each other out. So we have 2x over x minus 2 times x plus 2 equals 6 over x minus 2 times x plus 2. Since our denominators are the same, we know that the numerators need to be the same in order for these two sides to be equal, which means we're solving 2x equals 6 to finally get that solution for what x is. So divide by 2, and you see that x equals 3. The next step, and probably the most important step, is to go back and check that answer. Remember, whenever you have a rational equation or a rational expression, you need to make sure that your answer doesn't give you an undefined. So we don't want a 0 in the denominator. And this should be a pretty quick check. We have 1 over x minus 2, which is 3 minus 2, plus 1 over x plus 2, which is 3 plus 2, equals 6 over x squared, minus 4. 1 over 3 minus 2 is 1 over 1, plus 1 over 5, equals 6 over 9 minus 4. So on the left we have 1 plus 1/5, or 1 1/5. And on the right we have 6 over 5. And 6 over 5 simplifies to 1 1/5. So that does indeed check, and we know that x equals 3 is a possible solution, and it is the solution for this rational equation.